This is the fourth in a series of videos in which I'm attempting to repair a pair of HP9100B calculators. In the previous video we got one of them working. I did skip through the repairs for that, and I will be coming back to go over those in some detail in future videos. But the next step is to look at the second unit, and we'll use the first largely working unit now as our go-to comparison machine. So as we start to work our way through this one, and if you recall, this one doesn't work, it doesn't respond to key presses, and we can hopefully use the first one as a basically a test comparison unit to look at the various signals, and in conjunction with that we'll look at the schematics and go through each of the boards in turn to see exactly what we need to do to get this unit working. So we'll start off by powering this up and just recap on what the fault was. So if we turn this unit on, it is drawing current, it's drawing about 0.4 amps, and give it a few seconds to warm up. There is no display panel for the register labels on this unit, so it's kind of difficult to see when it's powered up. But it is drawing power, but it won't boot up properly. We can see a brief glow, and if you recall, we can possibly get this to do something by turning down the mains voltage, and this will essentially change the way that it powers up. And it does sometimes provoke it into displaying something, which is obviously what we're trying to do here, but it is very touchy as to what voltage it needs to actually do anything. So we'll try putting it into program mode and rebooting. Turn the voltage up slightly. And as you can see, at some point it does boot up. It doesn't respond to key presses, so it's not even flickering, so it's quite possible that the keyboard is not working at all because none of the keys do anything. But if we switch over to program mode, we can see that the display does change. So it is actively scanning the registers, the display registers, and it does seem to be coming up with some partially meaningful values. And if we switch over from fixed to floating point, the values do seem to be reasonably consistent with what we would expect to see. On top of that, if I change the number of decimal places that are supposed to be displayed, that also works. So it is working to a certain extent, but none of the keys work. Now, okay, what I could do here, if it's possibly a keyboard fault, is we could try inserting a memory card, and let's grab a memory card, and that will of course to a certain extent bypass the keyboard and should allow us to change some of the values that are in memory. So we'll try inserting a memory card. Okay, so the memory card won't go into the reader, so it's possible the reader's stuck. Okay, we'll have a quick look at the reader. If the reader's halfway through a cycle and it hasn't completed that, there are a couple of micro switches on it that, if they're not closed, then it disables the keyboard. It stops you pressing keys while the card's being read. So we'll have a quick look at that. I'll just move the camera and open the machine up, and we'll have a look at the reader. Okay, so we've got the reader down here, and it definitely looks a bit the worse for wear. Doesn't look right somehow. You probably can't see it, but this friction wheel that's used to drive the card out, so the way this works is you press the card in manually and then it will drive it out while reading it, and this is the read-write head. But this is not sitting, this wheel's not sitting square, so it's possible this has had an impact during shipping. There should be a gap between the top of this and the power supply. I can't see any marks on the power supply, so not quite sure how that could have happened. but it looks like this has been knocked down, so okay, that won't turn, and the switch is indeed open. There's a cam on here that runs round, so when you press the write or read buttons on the card reader, this motor starts to turn to drive the card out, but at the same time this cam disables the keyboard, so it could just be that we've got the keyboard disabled. It is clicking, so it is definitely open. That one's closed, this one's open. It's going to, well, you can't see it. Okay. I'm just going to close the lid and reposition the camera. Okay, I haven't done anything else, I've just closed the lid, but now it's actually doing something. And it's actually working, so it may just be as simple as the reader was damaged, which will be a bit disappointing if that's all we have to do. We'll try putting it into program mode and see what happens there. We'll just try resetting the address first. See if we can actually write values into the memory. It doesn't look quite right. Okay, it's partly working. This display's not quite right. It is storing the values we're typing in, but the address is not showing up correctly. So this should be showing us the address, and that is incorrect. Although the top and the bottom are showing it. If we ignore all the trailing digits, then it's actually working. It's showing us the correct values, but we shouldn't be seeing these values after. So what it's saying here is 0A, which is the address and the value. 0B is showing the value as well. And if we step the program onto the next address, then effectively this top line should move to the bottom and we should see 0.C, which we are. And we should keep stepping through. So that's actually working. If we go back to start, we should see the same sequence again, which we are. So it's kind of working, kind of not. This display's not working the way it should. So we're getting all these trailing zeros that we shouldn't be getting. Well, that may still have something to do with the reader switch. Okay, what I'm going to do is take the reader out and see if we can get that repaired. Also, we've made quite a big step forward here. I'm still going to dismantle this unit completely. I'd just like to see how far we can get it working before we do that. There is still an issue with the way the data is being displayed, but also this is quite a significant step forward because it does seem to indicate that the memory is working as it should. Quite what's going on with the display we'll have to look at later on, but for now we'll get the tape reader taken out, or the card reader taken out, and see what's going on with that. So I've removed the tape reader and I can't rotate it, it seems to be frozen. It should spin round fairly easily, but it just doesn't want to turn. So it may just be that the gearbox has frozen up. There's grease in here, and over time it can dry up. I don't want to force it because it might strip a gear. There's quite often plastic gears in these. So what I'm going to do is try and clean it up. There's some debris down here that's come from somewhere, and it does look like the remnants of grease. The pinch roller is free to turn, so it's not that. Okay, the pressure roll is also fairly free, that rotates freely, so it's definitely an issue in this gearbox somewhere. So what I'm going to do is pop this out, see if I can get it to free up, and if this will, it might be that it's trying to drive itself to the home position, or it might be that the electronics has failed and it's not trying to turn it at all, which may be why it froze in the first place. But either way, I need to get this freed up and see if we can get it to actually rotate. What I'm going to do first is actually just measure across these 2 points to see if this is trying to drive itself back to the home position. Okay, I've taken the motor out of the card reader and managed to free it up. It was just kind of consolidated grease and grime and dirt, so it now spins quite freely, but it's still not being driven by the electronics. It's possible this being frozen has burnt something out. What I'm going to do now is disconnect the motor and just try and drive it. It's a 15 volt motor. I'm just going to try and drive it with a DC voltage and see if it will rotate at all. I suspect the fault might lie in the electronics, so we're probably going to have to look into that. But either way, it does look like this just not returning to its home position is what was causing the machine to appear to be frozen. It's still not displaying the data correctly, of course, and it doesn't boot up reliably unless the mains voltage is quite low, so there are quite a few other issues on this machine. But the next thing I'm going to do is pop out the drive electronics. In fact, there's some test points along the top edge of the controller card. So I think what we'll do, before we go and start dismantling this, we'll have a bit of fun, see if we can figure out what's going on with this, and see if we can get it to turn the motor. But next step is to see if this motor is actually viable and will turn in the first place. So that's the next step. Okay, I don't think we're the first ones to have been here. This wasn't soldered on in the way I would expect it to be from the factory, so looks like someone may have already attempted this. But I've got these connected to the bench supply, and what I'm expecting to happen here is this to work. I'm pretty sure if the motor wasn't working, somebody could quite easily have fixed it, so chances are the fault's in the electronics. We'll power this up. I've got the bench supply set to 5 volts. It is a 15 volt motor, but we'll see if this spins fairly freely, if it makes any weird noises, and what current is drawn. So I'll power the supply up, and it is indeed turning, and it's drawing 17 milliamps at 5 volts. So I'll up the voltage. Okay, so that's 10 volts, it's drawing 30 milliamps with no load. It does appear to have reasonably good torque. And I have checked, there is no voltage coming out of the drive lines at all, so it does appear that we have a fault with the electronics. I'm going to leave this running for a few minutes just to make sure that it doesn't overheat or start binding up again, and also to just exercise it a bit. And hopefully what we can do now is start fault finding on the control board. Okay, so this is the control board for the reader, and sure enough we have a shorted tantalum cap on this board. I'll get that swapped out, plug it back in, and we'll see if that gets us any nearer. I can't find any faults with the actual driver devices, so hopefully it is just the capacitor. and that will bring this back to life. So I'll get this plugged back together and we'll see if that's going to resolve the problem. Okay, I've got the board plugged back in and I'm going to power it up. I have to refit the board, of course, because it plugs into the motherboard, and if this is now working, we should see this motor turning. The switches aren't hit, of course, because the cam's here, so it's going to continuously drive trying to find the home position where the cam hits the switches. So hopefully this will start to spin. So let's get this powered back up and see what happens. And it is indeed spinning, so if I press the micro switches in, that should stop. Which it does. Okay, I'll get this reassembled, we'll put it back into the machine and see if we can actually get a card to read. Okay, well, we got the motor working and I was in the process of reassembling this, and I was trying to set the cam timing to suit the flat on the friction pulley. I've realised this doesn't have a flat. So the way this is supposed to work is the cam stops the pulley in a certain position, and on the back of this assembly there's this small idler pulley. This white one is to hold the card against the read-write head, but this black one on the right here, this is fixed, but the friction pulley should have a flat section that when the cam reaches the home position and stops the motor turning, then that flat section is opposite this pulley and it leaves a gap between this idle pulley and the friction roller, and then you can insert the card. If that gap's not there, then you can't insert the card, because obviously you'd be trying to turn the motor by pushing a very thin flexible card, and it's not going to be able to do that. So I was looking for the flat on here to be able to set the cam position, and there isn't one. So it doesn't really matter where it is as far as the motor's concerned, but when you put the cam on, you have to set it so that that flat section is in the correct location when the cam hits the switches. And there just isn't a flat on here, so it's not a big problem. I can just take this off and put one on there. But it looks like someone's had an attempt at repairing this, and I had assumed it was working at some point and the failure was just the capacitor, but it looks like this hasn't worked for quite some time. Chances are the original friction pulley just disintegrated and somebody put this on and didn't realise it was supposed to have a flat section, which you wouldn't if you'd not seen an original, and the reason they were changing this presumably is because the original one had fallen to pieces. So okay, I'll get this back out. We'll put a flat section on here. It doesn't need to be much, it's only about 1/2 millimetre, just enough to give some clearance for the card, and then we'll try refitting this, setting the cam timing, and see if that actually causes it to work. Okay, well, I don't know how clearly this will come across on the camera, but I've cut a flat section on this O-ring. I've left a bit of O-ring there between the ring and the pulley itself. If I have to go any further than this, then I'll take the O-ring off and file the pulley. I don't want the aluminium proud of the rubber, because that will damage the card. So what I can now do, hopefully, is refit this. Try not to get in the way of the camera too much. And then we need to get the boss on at the back. Okay, so that's the first. Just rotate the pulley so the flat's in the correct location. We'll fit the second bush into place so that we've got the entire assembly correctly aligned. Okay, so both of the bushes are now in place. I haven't refitted the screws, and if this is okay, and if we have sufficient clearance, then I should be able to insert the card without too much friction. If there's too much friction, then I'll need to reduce the size of the O-ring even further, but to do that I'll need to take some of the aluminium off the actual pulley. So just make sure this is correctly aligned. Which I think is there, and then this should fit in here without too much friction. So you see it slides in quite nice and easily. But as we start to turn this, then it should drive the card, and now this is captured, I can kind of dangle the entire drive from this. So we need to find the lowest friction point on this. Which is there, and then that's the position we have to set the cam to hit the micro switch, and that way when this comes to a standstill we can still remove and insert cards. If you don't do that, you won't be able to get the card to go into the reader. So I'll finish assembling this and then we'll see if it actually works. Okay, well that turned into a bit of a saga. After I reassembled it all and put a card in, it wouldn't eject the card. The motor would spin, but it would just turn round, and effectively the spindle was doing what it was supposed to, but the card wasn't moving. And it turned out that the O-ring was slipping on the pulley, so the pulley was turning but it wasn't turning the O-ring. And it's just, I think what's happened here is somebody had made a replacement pulley assembly and the O-ring was the wrong size, didn't have a flat on it, and just wasn't really suitable for this particular purpose. So what I had to do was obviously take it all apart again, and when I looked at it more carefully I also found that the shaft had been bent. So the shaft this sits on, it wasn't a long way out, it was about probably 0.5 millimetre or so run out at this pulley end, but that's enough on these tight tolerances that it was binding up. It would turn halfway around and then bind up. Also I think whoever made this had Loctited the pulley to the shaft, and unfortunately they got Loctite all the way down and including into the bushing, so the whole thing was tightened up and it wouldn't spin freely. So I straightened the shaft, took the opportunity to put a flat onto the actual aluminium pulley as well as the O-ring, bonded the O-ring to the pulley, so it's now one piece in effect. Also the grub screw had been over tightened on the cam, and also the cam itself was damaged at the base, and that's where it hits the other micro switch, so it was stopping in the wrong place. So I corrected all that. I've now adjusted it so that the flat on the O-ring is in the right place relative to the home position as dictated by the cam. So what I should be able to do now is insert a memory card, and when I press the read button it should eject the card, and you can see it is indeed doing that correctly. I should also be able to read the card. Okay, so you won't be able to see this, but I'm going to set the 0 address, and now I'm going to try to read the card into the machine. And it's read the card. I'm just going to switch over to program. I'll have a quick look on the display. I'll show you this later on, but I just want to see now if it's reading the card, which it is. So that looks like a success. What I'll do now is get this bolted back into the machine, and then I'll demonstrate it so you can see the display as it reads the card. It's still binding a little bit. I still need to adjust it slightly, but at least it is working now, and it does seem as if though it was a combination of things. Mostly the repair that had been made wasn't really going to be successful, so hopefully this is a proper long-term fix. Okay, I've got the lid closed. We'll clear the display, and we will try to read a memory card. So it goes in nice and freely, and it should have read some data, which it has. So that's now working. The memory card reader does now work. It still needs a bit of fine tuning just to make it a bit smoother, and chances are as it's used it will free up as well. So that's another step closer to what we should be seeing. And also notice that as we now step through the program, the display is reading correctly. I think that was a side effect of the card reader not reading correctly, and it's that's been cleared up as a result of us fixing the reader. It may even been something to do with the shorted cap on the reader interface, but either way, this is now working the way that it should do. What I'm going to do as a final step before we start dismantling this is to try and run the diagnostic program. So we'll prepare to read the card. We'll put the diagnostic program card in. You can see we're getting the same value we got the last time we tried this. Read the second side. Okay, and we'll try and run it and see what happens. Okay, that's looking quite promising. It's going through the test. We'll see how far through it gets. You can see the display is tilted, but again, as I said, that's something that we can adjust later. And it should go all the way through to 9 and then back to 0 if it's working. Okay, so it's all the way around. So unfortunately, it looks like this is now actually working. Okay, but as I say, we'll go through these anyway and try and see exactly how all the parts work. I'll strip this unit down completely, go over each board in turn, explain how all the circuitry works, and if you've got any questions or want to see anything in particular, then please leave a comment.